Hello everyone. This is your course instructor Monisha Raj KH, Assistant Professor, Department of Electronics and Communication, Sai Vidya Institute of Technology. In this lecture video, we'll be studying about the numericals of Module 3, that is information channels. The first numerical goes as such. A binary symmetric channel has the following noise matrix with source probabilities P of x1 equal to 2 by 3 and P of x2 equal to 1 by 3. Here, the conditional probability matrix has been given as 3 by 4, 1 by 4, 1 by 4, and 3 by 4. They are asking you to determine h of x, that is input entropy, h of y, the output entropy, h of x comma y, the joint entropy, h of y by x, and h of x by y, that is the conditional entropy. In the question, they have clearly told you about the input probability values as 2 by 3 and 1 by 3. By using these values, we can calculate the input entropy, that is h of x. How to do that? H of x equal to summation I equal to 1 to 2 p of xi log of 1 by p of xi to the base 2. Substituting those values, that is 2 by 3 and 1 by 3 in the equation, we get h of x as 0.9183 bits per symbol. Next, we have an equation known for the relationship between the probability of the conditional probability, joint probability, and the input probability. So, using that equation, that is P of x comma y, that is the joint probability equal to conditional probability into input probability values. Using these values, we can calculate the joint probability. In the question, we have given a conditional probability matrix and we know the input probability matrix. So, substituting these two matrices, that is, this is the joint probability matrix given, this is the input probability matrix. Here, the multiplication of the matrix is not the regular mathematical multiplication. It is that x1 is 2 by 3, while x2 is 1 by 3. So multiply x1 with the first row and multiply x2 with the second row. By doing so, we get the joint probability matrix as 1 by 2, 1 by 6, 1 by 12 and 1 by 4. Now we have joint probability matrix. From this, we can calculate the output probabilities. How to do that? The first row here is the x1, the second row here is the x2. In similar way, the first column is y1 and the second column is y2. That is, x represents input and y represents output. So, how will you calculate the output probabilities? P of y1 equal to first column, addition of the values of the first column, that is 1 by 2 plus 1 by 12 equal to 7 by 12. Next is P of y by y2, that is 1 by 6 plus 1 by 4 equal to 5 by 12. So this is the output probability values. Now we have joint probability matrix, we have output probability values, we have input probability values. From this, we can now calculate the output entropy value. How will you calculate that? Using the formula h of y equal to summation j equal to 1 to 2 p of yj into log of 1 by p of yj to the base 2. So substituting these two values, that is 7 by 12 and 5 by 12 in the equation, we get h of y as 0.9799 bits per symbol. In a similar way, we can calculate joint probability or a joint entropy by using the probability matrix. That is joint probability matrix 1 by 2, 1 by 6, 1 by 12 and 1 by 4. So joint entropy goes as h of x comma y equal to summation I equal to 1 to 2 into summation j equal to 1 to 2 p of xi comma yj into log of 1 by p of xi comma yj. Substituting those values, that is the joint probability matrix values, we get the joint entropy value as h of x comma y equal to 1.7296 bits per symbol. In the theory part, we had studied the relationship between the joint entropy, conditional entropy, and the output entropy. By using the same relation, now we can calculate the conditional entropy values. How to do that? H of y by x equal to h of x comma y minus h of x. So we know the value for h of x comma y, we know the value of h of x. Substituting those two values, we get the conditional entropy. That is 1.7296 minus 0.9183. So h of y by x equal to 0.8113 bits per symbol. Similar way, we can calculate h of x by y equal to h of x comma y minus h of y. So here also we know the value for h of x comma y and h of y. Substituting those two values, we get h of x by y value as 0.7497. This is one of the type of problem. The next type goes as such. The joint probability matrix for a channel is given below. Compute h of x, h of y, h of x comma y, h of x by y, and h of y by x. In this question, they have given you the joint probability matrix directly. But in the previous question, they had given you conditional probability matrix. So from this matrix, we can directly get the input probabilities and the output probabilities. In the question, they haven't mentioned anything about the input probability or output probability. From the matrix, that is a joint probability matrix, we need to calculate the input probabilities and the output probabilities. How to calculate that? The input probabilities are the sum of the values in the rows. So this is x1, first row is x1, second row is x2, third row is x3, and the fourth row is x4. Similar way, the output goes as the first column is y1, the second column is y2, the third column is y3, and the fourth column is y4. So after calculating this, we get the values as p of x, that is the input values are 0 0.3, 0 0.2, 0 0.3, and 0 0.2. This is the sum of the values of each of the rows. And p of y, that is the output value, goes as 0 0.1, 0 0.15, 0 0.5, 0.25. That is the sum of the probability values of each of the columns. So we know P input probabilities and output probability values now. From this, we can calculate the input entropy and the output entropy using the formula h of x equal to summation I equal to 1 to 4 p of xi into log of 1 by p of xi. So this is the input entropy. Using these probability values and substituting in the equation, we get h of x as 1.9705 bits per symbol. In the similar way, we can calculate output entropy value using these values, that is p of y equal to 0 0.1, 0.15, 0.5, and 0.25. That is substituting the equation h of y equal to summation j equal to 1 to 4 p of yj into log of 1 by p of yj to the base 2. So h of y value will be 1.7427 bits per symbol. Now we have calculated input entropy and output entropy. In the question, they have given you the joint probability matrix. From that matrix, using those values, now we need to calculate the joint entropy value. That is h of x comma y equal to summation I equal to 1 to 4 into summation j equal to 1 to 4 p of x comma y into log of 1 by p of x comma y. So substituting those probability values in this equation and calculating it, we get h of x comma y as 3.1219 bits per symbol. So in the similar way, as we solved for the previous question, we can also find the probability we can also find the conditional entropy using the relationship. That is h of x by y equal to h of x comma y minus h of y. That is, we know the value of h of x comma y minus h of y is 3.1219 and h of y is 1.7427. We get the value as such. Similar way, h of y by x equal to h of x comma y minus h of x. Substituting the values of h of x comma y and h of x, we get h of y by x value. This is one of the type of the problem. Thank you. We'll continue with the other problems in the next video.